In question number 21, they have asked us if f of x plus y by 2 equals to fx plus fy by 2 for all xy belongs to real values. F dash 0 is minus 1, f0 is 1, find out f dash x. Okay, so what I'm doing here is, we have been given that f dash 0 is 1. It implies limit h approaches to 0, f of h minus f of 0 divided by h. Now, f0 is nothing but 1, therefore we can say that limit h approaches to 0, fh minus 1 by h is nothing but 1. Is it clear? So let us just keep this thing in our hand and let us try to find out what is our f dash x. F dash x, from the first principle we can write limit h approaches to 0, f of x plus h minus of fx divided by h. Is it clear? Now we have been given the functional equation, this one. Okay, so in place of x I am putting 2x and in place of y we are putting 2h. So what we are going to get from here, f of x plus h is nothing but f of 2x plus f of 2h divided by 2. So let me just replace this. And after taking LCM, we are going to get something like this. Is it clear to all of you? Now, again in the functional equation, we are putting in place of x as 2x and y as 0. So what we are going to get here? Fx is nothing but f of 2x plus f of 0 divided by 2. So we are getting 2 times fx equals to f of 2x. And f of 0 is nothing but 1, so we can write this thing as 1. So what we are getting? We are getting f of 2x minus 2 times f of x is nothing but your minus 1. Is it clear? So f of 2x minus 2 times f of x can be replaced by minus 1. So we are getting what? Limit h approaches to 0, f of 2h minus 1 divided by 2h. Is it clear? Now as h approaches to 0, 2h also approaching towards 0. So we can write 2h over here also. So this is nothing but your f dash 0. Is it clear? Because 1 is nothing but f of 0. Because this thing you can write it in this way. F of 2h minus f of 0 divided by 2h, which is nothing but your f dash 0, which is nothing but your minus 1. Is it clear? Therefore, f dash x is nothing but minus 1. Your option D is correct for question number 21. Option D is correct for question number 21. Is it clear to all of you? In question number 22, they have given that gx is the inverse of the function fx. So gx is nothing but f inverse x. And they have said that f dash x is 1 by 1 plus x cube. We have to find out what is our g dash x. Now since gx equals to f inverse of x, therefore we can say that x is nothing but f of gx. Now let me differentiate both sides with respect to x. We are going to get okay, therefore our g dash x is nothing but 1 by f dash gx. Is it clear? Now f dash x is 1 by 1 plus x cube, therefore f dash gx will be 1 by 1 plus gx whole cube. Is it clear? So it will go up and it will give us 1 plus gx whole cube. Is it clear? Therefore, your g dash x is nothing but 1 plus gx whole cube. Therefore, our option C is correct for question number 22. Have you understood this problem? In question number 23, they have given that fx is this one when x is not equals to 0. then for f to be continuous everywhere, find the value of f of 0. Is it clear? Since the function is continuous everywhere, so we can say that f0 is nothing but limit x approaches to 0 divided by 1 by 5 minus 2. Is it clear? Now you observe, if I put x equals to 0 over here, we are going to get 256. 256 is nothing but 2 to the power 8, so which gives you only 2. So 2 minus 2 is 0. And in the denominator, if I put x equals to 0, we are getting 32 to the power 1 by 5, which is nothing but 2. So again 2 minus 2 is 0. Therefore, this is nothing but your 0 by 0 form. This is nothing but your 0 by 0 form. So we can apply L'Hopital's rule. So what we are doing here is we are differentiating numerator and denominator separately. 1 by 8 minus is here. 256 minus 7x to the power minus 7 by 8 divided by, in this case, 1 by 5. Oh, I'm sorry, one more thing. 7x, so it will give you plus 7 over here, isn't it? Now, in the denominator, what we are getting? 1 by 5, 5x plus 32 whole to the power minus 4 by 5. And again 5 will come outside, right? So we are getting basically what? So it's now, if I put x equals to 0 over here, we are going to get, in the numerator we are getting 7 by 8, and this thing will be into 2 to the power minus 7, and in the denominator we are getting 5 goes off, so it's 32, so 2 to the power minus 4. Is it clear? So we are left with what? 7 by 8 into 1 by 2 cube. That is 7 by 64. Am I correct? So your answer is 7 by 64. So none of these options are matching. Therefore, our option will be none of this. That is, option D is correct for question number 23. Is it clear to all of you? Absolutely. Now in question number 24, they have given, if Sn is sigma k from 1 to 4n minus 1 whole to the power k into k plus 1 by 2 into k square, we have to find out the value of S100. So in place of k, I am putting 1, 2, 3, 4 till 4n. That is, I am just expanding the sigma sign. So what we are going to get for Sn? Look it carefully. In place of k, if I put 1, we are going to get this thing goes on, right? And this thing goes on. Okay? So the last term will be what? Minus 1 whole to the power 4n into 4n plus 1 divided by 2 into 4n square. Now observe carefully, this is nothing but this will give you nothing but 1. Why it is so? Because the power is even. Yes or no? Because 2n into 4n plus 1. 4n plus 1 is odd, but 2n is even. Therefore, you will get the even number. So minus 1 to the power even will give you positive. So ultimately, this part will go off. Only 4n square will be there. Now, if I just make a group of this, like minus 1 square, minus 2 square, plus 3 square, plus 4 square, plus again minus 5 square, minus 6 square, plus 7 square, plus 8 square, and this thing goes on, right? Okay, total number of terms are 4n. So we are taking 4 in one bracket. So n times you will get, because taking this 4 as your one term, you will get n such terms. So the nth bracket will be look it carefully, the nth bracket will be, it is minus 1 square. The first term of the nth bracket will be, here is minus 1 square, minus 5 square, and this thing goes on. So it will be minus 4n minus 3 whole square. Then it will be 4n minus 2 whole square. Then it will be 4n minus 1 whole square, and then it will be 4n squared. Am I correct or not? Have you understood this? How I am getting this one? It's pretty simple. You see, it's 1 square, 5 square, so 1, 5, and this thing goes on. So when it will be nth term, a plus n minus 1 into d. So that gives you what? 4n minus 3, right? That's exactly what I have written. Why I have given a minus sign? Because it all starts with a minus sign. That is why it is coming like that way. Okay. Your Sn is nothing but sigma of 4n minus 3 whole square, sigma of 4n minus 2 whole square, sigma of 4n minus 1 whole square plus sigma of 4n square. Yes or no? Okay, so I have written this thing in sigma, where n starts from 1 till n. So if I open it, what we are going to get, look it carefully, from here we are going to get 4n square, sigma minus sigma 4n square. From here we are again going to get minus sigma 4n square. Here we are going to get sigma 4n square and sigma 4n square. So it will all get cancelled. Now, then from here, twice AB will give you what? Minus sigma 24A. And this minus will become positive. Again, this one will be also positive. Sigma 16 in. From here we are getting minus sigma 18. This term to already get cancelled. So what we are getting only from this one, what we are getting? We are getting 32 sigma n, right? Now what about the constant term? Let us see. Here we are getting minus, look it carefully, minus sigma 9. From here we are getting sigma 4. From here we are getting sigma 1. That's all. So what we are getting basically minus 12 sigma 1, right? Is it clear? Okay. So what we are getting? Sigma of n is nothing but n into n plus 1 divided by 2, and sigma of 1 is nothing but, since your n starts from 1 till n, so it sigma 1 will give you only n. So what we are getting? 16 n into n plus 1 minus 12n. So we are left with 16n square plus 4n. So if I take 4n common, so it's 4n plus 1. So it is 4n into 4n plus 1. Thus, oh, we need to find out S100. So it's okay. This is your Sn, right? This is your Sn. So S100 will be what? 4 into 100 into 4 into 100 plus 1. So we are getting 400 into 401, right? 400 into 401. Thus our option A is correct for question number 24. Option A is correct for question number 24. Have you understood this problem clearly? In question number 25, we have been said that fx is this, where this one is the greatest integer function, and we are having Sgn x. Sgn x is nothing but your signum function. Okay, Sgn means the signum function. We have to check whether the function is continuous or not at the point x equals to 0. Now, if you observe the options which are given to us, they have said whether LHL exists, RHL does not exist, both of them does not exist, both of them exist, and all this. So we will just check the left hand limit as well as the right hand limit at the point x equals to 0 in this case. First we will see that if LHL equals to RHL, Then we will find out what about the value of the function at that point. If these three things are same, then we will say they are continuous. Otherwise, accordingly, we will give the option. So, let us start with the left hand limit at x equals to 0. Limit h approaches to 0, f of 0 minus h, which is nothing but h is a very small positive number. So minus h, so what we are getting? In place of x we are putting minus h, so we are getting box mod minus h e to the power again h squared minus h plus mod of minus h, box ends there, divided by e to the power 1 by h square minus box of minus h signum sine of minus h, box ends there. Is it clear? Now, limit h approaches to 0, mod of minus h is nothing but only h, e to the power h square. So minus h, this will be plus h divided by e to the power 1 by h square minus signum of sine minus h. Okay, h is very small positive number. So minus h will be very little than 0. Okay, it is negative but very little than 0. So it will be nothing but minus of sine h, which will give you a negative, very small negative value. So signum of any negative will give you minus 1. So we are going to get here as box of h only. Is it clear to all of you? Now you observe here h and h goes off. So box of this part will give you exactly 0. Okay. But in the denominator, so in the numerator we are getting exactly 0. But in the denominator, observe it carefully, box of h, since h is very small positive number, so this part will give you what? This part will give you exactly 0. Is it clear? Exactly 0, because box of h is very small positive number, so box of h will give you 0. Now what about this? As h is approaching towards 0, 1 by h square is approaching towards infinity. Yes or no? So e to the power infinity will give you infinity. Now the thing is that h is approaching, as h is approaching towards 0, 1 by h square is approaching to a very huge value. We are not getting the exact value since it's a limit. So we are not getting the exact value, but we can say that e to the power 1 by h square is approaching to a very huge value. Very large value. Okay? Very large value. But in the numerator we are having 0. So we are going to get the value of the left hand limit is nothing but 0. Have you understood this? E to the power 1 by h square, as h is approaching towards 0, this one is approaching to a very large value. Very large value minus 0 will give you a very large value. But in the numerator we are getting 0. So ultimately you will get the value as 0. Is it clear? Now let us check the right hand limit. We got left hand limit as left hand limit at x equals to 0. We got it as 0. Now let us check the right hand limit. F of 0 plus h, which is nothing but your fh. So in this case, since I told you that h is very small positive number, so mod of h can be simply written as h over here. Again, this one is coming to 2h divided by e to the power 1 by h square minus. Look at carefully. H is very small positive number, so sine h is little positive. Okay, it is little more than 0. So it is positive. So signum of sine h will give you 1 only. So this one is coming to box of H. So box of this will give you exact value of box H will give you 0. So in the numerator again we are getting 0. Look it carefully. Exactly 0 we are getting in the numerator. But in the denominator, similarly, as H is approaching towards 0, e to the power 1 by H square is approaching towards a very large value, minus this one will again give you 0. So ultimately we are going to get the value as 0. Therefore, the right hand limit at the point x equals to 0 is also 0. So right hand limit at x equals to 0 is 0. Again, the value of the function is 0 at x equals to 0. Hence, we can say since the left hand limit, right hand limit and the value of the function are all equals to 0, so we will say that the function is continuous at the point x equals to 0. Have you understood this problem clearly? Okay, now the option A is correct for question number 25.